Hello everyone, welcome to Bright Engineering. Today we are going to look at how you would convert a complex number from rectangular or Cartesian form to polar form. So most often than not, you are given complex numbers in the term of real and an imaginary parts, right? So always the real part is the x component and then the imaginary part is the y component. So when you want to convert from this rectangular or Cartesian form to polar form, we are going to get it in the form of r cos theta plus ri sine theta. So because r is common to both, you can just bring r out and into brackets cos theta plus I sine theta. Right. So the only thing that is new here is the introduction of the cos and then the sine, because when we were calculating for modulus and argument, we found out how to calculate your modulus and how to calculate your argument. So in the same way, when we want to find or want to change it to polar form, we just simply have to calculate our modulus, our argument, and then insert it into this function. So let's look at the first example. So when you have this and we want to find our modulus, we know that r is equal to root of minus 3 squared plus minus 3 squared, which is going to give us root of 18, and this is the same as 3 root 2, right? And if you have to find our argument, that theta is equal to tan inverse of the imaginary minus 3 over the real, which is also minus 3, and this is going to give us tan inverse of 1. When you punch this into your calculator, please, it's very imperative that you change it to radians on the calculator. This is going to give you 1 over 4 pi. But then interestingly, we are looking at this particular rectangular component or rectangular form using its signs. So let's draw our graph and then see how it's going to look like. So when you have a graph like this, we know that here is the positive y axis, this is the negative y axis, here is positive x, and here is negative x axis. You have the x axis to be negative and the y axis to be negative, so it means that theta fall within this quadrant. So we can draw, you can see here is our 3, here is our 3, we can draw it here, and then always the hypotenuse is linked up with the x axis like this, and then the theta is going to be this side. But then we don't use theta because we'll be able to find our argument. Always, theta should be the angle between the hypotenuse and the positive x-axis. So it's either we are adding this 180 degrees to this angle, or we are subtracting this particular angle from this total 180. So if you want to add this total 180 to this, it means that we are going to get theta plus pi. Note, this is in rad, so 180 is the same as pi. So we are going to get 1 over 4 pi plus pi, and it's going to give us 5 over 4 pi, and this is the angle that we are going to use, or this is the argument that we are going to use. So when you have this, then straight away we can insert it into our formula, and then we get r cos theta plus I sine theta is going to give us r, which is 3 root 2 cos of 5 over 4 pi plus I sine 5 over 4 pi. And this is going to be our polar form of this rectangular complex number.